In this video, we are going to look at the first two steps for constructing a confidence interval for a population proportion. And the first step is to figure out what the point estimates are. And so remember, point estimate, another term for this would be sample statistic. And when you are estimating the population proportion, your sample statistics are p hat and q hat, where p hat is equal to x over n, and x is the number of successes. And I'm going to put successes in quotes because it doesn't necessarily mean success in the terms that you would normally define it. So in this case, choosing the vegetarian option would be considered our success outcome, but that's not necessarily a successful thing. So kind of keep that in mind. It's essentially just the number of people that responded one way. And so that's what p hat is equal to. And then q hat, this is equal to 1 minus p hat, and it's essentially the number of failures, right? So we can put number of failures and put failures in quotes again. So to find the point estimates for this example, we're going to have that p hat is equal to x over n, where x is equal to 66 and n is equal to 188. And q hat is then equal to 1 minus 66 over 188. And this is equal to approximately 0.65. So now if we look at the second part of this example, it asks us if the requirements are satisfied for constructing a confidence interval. And so the first requirement is to make sure that your sample was random, that there was no bias in your sample. And so yeah, we can see that our sample was random. The second requirement is to make sure that the p hat distribution is approximately normal. And so the central limit theorem tells us that if n times p is greater than or equal to 10 and n times q is greater than or equal to 10, then our p hat distribution will be approximately normal. However, we are not given the actual values of the population proportion p or the population proportion q. And so what we do is instead we use their approximations, right? So we are going to make sure that n times p hat is greater than 10 and n times q hat is greater than or equal to 10. And so n times p hat, that's equal to 66, which is definitely greater than or equal to 10. And n times q hat is equal to 122, which is definitely greater than or equal to 10. And so here we can say yes, the criteria are satisfied, or the requirements are met.